Greetings. We have now Ville Malmivaara from Geosyntech Consultants, who would be talking with us uh, how are tailings and mining waste areas operated, but it's mining waste disposal in Finland specifically is what he's going to talk about. So we look forward to listen to your lecture, and the stage is yours.
Thank you, Sandy, and thank you all for letting me be here together with you. It's a great honor, especially with the great presentations that we have had so far. Before presenting myself more, we have a way of starting the meetings. We always do a safety share, and this time I have chosen to tell you about the emergency exits. One is here and the other one is there. In case of a fire alarm, we will go out, and behind my back we will gather to the square. There is no fire drill being planned, but in case you hear the fire drill, then we immediately leave the premises. Yes. I'm a geotechnical engineer. I studied hard and long here in Aalto. It was that time called TTK, and been working with the geotechnical problems ever since. I've also been involved with the mining industry over 15 years so far. I've also had several managerial positions, but the heart has always been with the geotechnics, so bear with me with the presentation also. Kirsi had 3 items, so do I: method for tailing disposal, impoundment techniques, and fraction settlement. Let's go. Okay, it's not take. Okay, now it's going. First, just to be clear, because I understood that there are many students here and also people who maybe not know what tailings is. So, in one sentence, man-made waste product of mining process. And to help understand this thing, would be good to... Yes, I took this picture so that while working in mine, where do we get the tailings? It's over there. So just... Also, we have been hearing good presentations today about what kind of geochemical properties ores have, and how the water balance has been handled in the mine areas, etc. So I'm not gonna go into these now, but go to the methods for tailings disposal. This one I took like a video, so you can see the water is the thing to look at this presentation. Slurry contains a lot of water. Thickened tailings has also water, but solid content increasing. Paste, solid content increasing, and dry stacking, solid content increasing. This picture also on the lower corner here, you can see how it varies from tailings slurry to the filtered tailings. It's increasing content, water content, field strength, but also costs. I also took this one so that you would get a better understanding of the different tailings methods, disposal methods. And as we are in Finland, I wanted to share the beautiful picture of the Finnish mines and the disposal techniques that we use here. Okay, so we have above water, single spigot, multiple spigot. This picture gives you an understanding when we are doing spigoting in the mine site. I will come back to that picture later. Then there's also a technique that can be done underwater. The ferry, or what should I call it, on the picture on the left side is the one that is delivering the tailings to the pond there. The advantages for that one is, of course, restraining the tailings and oxygen contacts, reducing oxidation and acid production. On the other hand, disadvantages are there will be differential settlements. It can cause the linear to be disrupted, and also I think this will it will damage. It can damage also the drainage system. To my knowledge, and if someone has better knowledge, then please tell. But we do all the disposal in Finland above water. The underwater disposal is more expensive, presents greater challenges, and a higher pond level is required to dispose the same amount of waste. As again, being a geotechnical engineer, I wanted to also bring some knowledge and understanding around water table inside these facilities. So this is, I will be showing you 3 examples, and this is a theoretical example because even with dry stacking, there will be moisture inside the facility. But in the case that there would be no water, this would be factor of safety, so meaning the safety towards the slip surface to occur. The value for this one in the mining industry is 1.5, so to give you some understanding for that one. Here we have a theoretical pond that is very straight there, and again it drops drastically the factor of safety. And then if we would have a case that the pond would be in a high position, the factor of safety would be drop dramatically, so not acceptable. Then fraction settlement. Here again, returning to the previous picture, we have on the spigoting site where the spigoting is taking place, we have a coarse fraction here, and with the water will also the fine fraction will go to the center of the pond. Let's see. Yes, and this will show the low strength, and the other one will show liquefaction. I don't know if this is, yeah, the liquefaction risk increases with the coarse fraction. Again, wanted to show you that where is liquefaction susceptible, it is within the gray areas. So you can't like think that this is not occurring in our facility. Have been speaking today with several people, and in the early days when I started, when we were talking about the liquefaction, we were always thinking about the dynamic liquefaction. And the dynamic liquefaction we went further was the thing, we said that there's no seismicity or that high seismicity. You can't say that there's no seismicity, there is seismicity, but not that high seismicity in Finland. So that was the way of handling it. But As we can see later on here in the presentation, the static liquefaction is in fact more challenging one. And here you can see that it can happen in a saturated and nearly saturated soils, such as loose sand, silts, and sensitive clays. So, what is static liquefaction? In a loose and saturated soil under shear stress, the undrained shear stress lies on the point A. Going from A to B, adding more stress, like doing a race in the facility, increases the shear stress in the tailings material. And then we reach the soil's maximum shear strength. What happens if we do add more load? Liquefaction that can trigger liquefaction, which will lead the soil structure to collapse, and we end up in a liquefied shear strength, which is much more lower than the original shear strength. I took a reminder, we just had the fourth landslide this year happening this week. This is from Brazil, 270 fatalities. I think many of you have seen this, but this every time it gives me the chills. And we have been discussing about drainage today, so you can see. Then what about liquefaction modeling? We have these traditional ways of modeling stability, LEM, limit equilibrium method, but in order to model this one, we need more sophisticated methods. And here's a traditional slide, but what it then happens will mean that there will be another and another and another, like a progressive slides there.